Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Fairwinds. My name is Cody J. Brown. I'm the host of TechStrong Learning, and we have an exciting presentation for you today. First, I have just a couple of housekeeping notes to cover. So first, today's session is being recorded. So if you miss any of our discussion or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude the live session. If you have any questions, we do want you to send those in using the Q&A tab, which can be found on the right side of your screen. That's also where you're going to find the chat tab, and this is where we want you to engage with your fellow audience members, engage with us, let us know your thoughts throughout today's program. We do have 2 polls that we'll be launching throughout today's webinar, so keep an eye out for those as they'll pop up on your screen. We do also have the slides available for download using the handouts tab on the right. So feel free to download those to follow along with today's webinar. Before we close, we'll also be giving away 4 $25 Amazon gift cards. So our topic today is Common Kubernetes Challenges Solved. And joining me is Rachel Sweeney, Insights Enablement Engineer at Fairwinds, and Grace Goody, Site Reliability Engineer at Fairwinds. Grace, Rachel, thank you both so much for joining me today. I'm going to go ahead and let you guys take the floor.
Thank you so much for having us. My name is Grace Goody. I actually just got promoted to engineering manager at Fairwinds, but I've really enjoyed working as a site reliability engineer. And in this talk, we're going to discuss some common problems people face in Kubernetes. And to solve these problems, we've got a number of different tools, mostly all open source, that will help you succeed at running Kubernetes and help you focus more time on providing value to your clients. The problems that we're going to discuss involve entry-level issues like how to think about deploying to a cluster and keeping our Kubernetes manifests organized, all the way up to more advanced problems like how to enforce policy and set up guardrails in the cluster. Kubernetes is very complex, but there is extensive tooling out there that can be invaluable in supporting your work. Whether you're just thinking about getting into Kubernetes or you've been using it for years, there is something here for everyone.
Hey everyone, so my name is Rachel Sweeney and I also work at Fairwinds. At Fairwinds, our mission is to be a trusted partner for Kubernetes security, policy, and governance so we can help customers ship cloud-native applications faster, more cost-effectively, and with less risk. We do this by contributing a lot of open source software for the community to use, as well as a software as a service offering and a number of other consulting and advisory services. We spend a lot of time working with clients, and we see a ton of problems come up in Kubernetes, ranging from the most common to one-off issues that affect niche areas of Kubernetes. And since we have such a great vantage point for seeing these problems across all different types of clients and clusters, we spend a lot of time, taking these common problems that we see to provide feedback and drive development for our software to help everyone solve these problems faster. So before we get into it, I want to go ahead and start with a poll. And the poll is, where are you in your Kubernetes journey? Are you learning about containers in Kubernetes right now? Are you planning to use it in 6 to 12 months? Are you using it in testing and development environments, or are you using it in production? Give you all a second to fill that out.
Thank you, Rachel.
I think this is the part of the presentation where you do that song and dance, Grace, the one you were practicing right before.
I thought you were going to do the interpretive dance today, Rachel.
I did it last time. It's your turn now. All right, so looks like we've got kind of split. A little more people are using it in testing and development. Some are using it in production. Some are just learning. So that's great. We've got a lot of good stuff that's going to cover that whole spectrum. And yeah, with that, let's go ahead and get into it.
Yeah, I think this is going to be a great group. Yes, and so before we dive into Kubernetes problems, we want to quickly introduce the Kubernetes maturity model. This is a model for thinking about the journey through Kubernetes. The problems that we're going to talk about today cover phases 1 through 5. This talk is going to start with some problems that come up at phase 1 or 2 of the maturity model. These involve deploying to Kubernetes clusters and keeping things organized. We'll then move on to phase 3 and start to figure out how we configure our deployments and resources to follow best practices before wrapping up with security, policy enforcement, and compliance issues that arise in phase 4 and 5 of the model. At Fairwinds, we've worked with all kinds of customers ranging throughout the maturity model, and we found that a lot of people face the same problems, which has led to the creation of quite a few open source projects to help our clients and other Kubernetes operators progress along the maturity model as their comfort and knowledge grows. These tools have the added benefit of allowing us to effectively manage many clusters without having to hire an increasing amount of engineers. The last thing I want to mention is that if you're new to Kubernetes and want to play around with it, we would highly recommend using Minikube or Kind to spin up a cluster on your local machine. Pretty much every tool we're going to show you can be downloaded to play around with yourself, so we highly encourage you to do so if it interests you.
All right, so let's get on to the fun stuff. One of the first things we think about when spinning up a new cluster is how to deploy. We consider this to be phase 1 to 2 of the maturity model. And you will use these first tools when you're setting up a dev or staging cluster, or when you set up your first prod cluster. And you'll likely continue to use these tools throughout your Kubernetes journey. So for those of you getting started, one of the first tools everyone should look into when using Kubernetes is Helm. And I'm sure many of you are already using Helm today. You can think of Helm as the package manager for Kubernetes. If you want to install Nginx, Prometheus, FluentD, or any other popular tool, Helm allows you to choose a release version and install the package in a relatively tidy manner. There's no need to worry about gathering up all the YAML files to install the deployments, the services, the custom resource definitions, etc., since Helm will take care of all of that for us, and we just need to give it the custom values that we require for our use case. So Ubuntu has apt, CentOS has yum, and Kubernetes has Helm. Now, if you want to take this a step further and keep all of your Helm deployment information in one location to keep your infrastructure as code nice and tidy, then Reckoner is another great open source tool worth looking into. Reckoner allows us to consolidate all of our Helm chart releases in one place using a declarative syntax. And it also allows installation of charts from a git commit, a branch, or a release. This is one of those tools that we use daily because it makes it much easier for us to manage hundreds of releases across dozens of clusters. So if we take a look here, Reckoner has this course.yaml file that defines all of the packages or Helm charts, if you will, that you want to install into the cluster. So right here, we've got this namespace of default, and if that namespace is not specified in any of the charts, that's the one that's going to be used. We can see here we've got 2 charts we want to install. We've got Grafana, and we've got the Polaris dashboard. Underneath each chart, we can override the defaults. So now we're saying we want the Grafana chart to go in the Grafana namespace, and we want to give it these values, specifically the image tag of 6.2.5. We also have the Polaris dashboard. We can see that's being installed from a Git repo here, and it shows what namespace it's going into, and we could pass in any other values that we want to override at that point. So from there, if you want to install all of these Helm charts, all you have to do is run reckoner plot course.yaml and then -- run all. And that's going to install both of these Helm charts, or if you have 100 of them, it's going to install 100 Helm charts all at once. You can also pass the -o flag for only. Instead of run all, you just say only, and then pass it the name of the chart. And that way you can target one specific chart instead of doing all of them if you only want to update one at a time.
Awesome. Thanks, Rachel. So at this point, you've got your clusters set up. You're using Helm and Reckoner to deploy Helm charts to the cluster. And now the problem arises of how to keep these Helm deployments up to date. A great open source tool that goes well with Helm and Reckoner is Nova. Nova is a helpful tool for quickly assessing all of the Helm charts installed in a cluster, what version they're using, and what's the latest version available. When installing or upgrading something, running Nova Find to quickly output all of this information for the Helm charts in the cluster makes it quite easy to see where things stand. Using Reckoner and Nova together for managing and deploying Helm charts allows us to move much faster and spend more time focusing on business needs. So here you can see we've run Nova Find, and we get a lot of helpful information about the different releases we have installed, the version, as well as the latest version that's available, and whether those versions are deprecated. So this is a super helpful tool in just seeing what you have installed and figuring out if you need to upgrade. So now that you've been using Kubernetes for a little bit, you've deployed some resources, and you're probably worried and wondering about all those unknowns in Kubernetes that you simply don't know about. These are the seemingly small, innocent things that can be the difference between having a secure cluster and being at risk. This brings us to tooling like Polaris, which becomes more useful as we start to build confidence and define our processes.
All right, so Polaris is a great open source tool. Get that bar out of the way. It's a great open source tool that scans all of the deployments in your cluster. It gives it a grade on how well it's doing, and it rates the cluster based on dangerous checks, warning checks, and passing checks. So, for example, do you know what the image pull policy is on every deployment in your cluster? There is a default. Are you happy with what you have right now? How about if you have memory and CPU limits and requests set? Or is host path enabled? How about liveness probes, readiness probes? The list goes on and on. All of these settings affect the security, the efficiency, and reliability of your cluster and your deployments. And Polaris helps you figure out if your deployments are following best practices. Host path is a great one to be aware of, since if it's enabled and an attacker has just enough permissions, they could mount the root file system of the node into the container, and they can continue their privilege escalation hunt and potentially gain access to your cloud account as well. You may think you're just mounting that one file or directory into your Kubernetes pod, but you've really just opened the door for the whole file system to be mounted in the pod for users or attackers with the right set of credentials. If you want to play around with Polaris, it can be run as a dashboard, a command line tool, or even an admission controller to block deployments to the cluster if they don't meet a certain threshold. So taking a look here, we can see this is an example of Polaris as the dashboard. We can see at the top, it's the production US East 1 cluster. It's got a grade of B+, a score of 88%. And we can see that out of the 133 passing checks, there's 31 warning checks and 1 dangerous checks. So Polaris is going to do a bunch of different checks based on category, whether they are health checks, looking at the images and containers, looking at networking, resources, security. And it can also break things down by namespace. We're looking at a deployment right here. And it shows each individual check, like host IPC is not configured. If you had this set up as a dashboard, you could actually hover over the little question mark, and it's going to bring up more information about why you might care about configuring the host IPC. You might not want all of these processes sharing, information back and forth. And so, yeah, it's a great way to just get a understanding of what's going on and how you've configured things, since there's a lot of things you're not aware of.
All right, so we've got things deployed in our Kubernetes cluster. We feel pretty good about how they're deployed since Polaris told us what we're doing right and wrong, and we've remedied the issues we found. One problem that comes up at this stage is how do we think about security and CVEs in our container images? We're pulling countless images into our cluster, and we need to figure out what types of vulnerabilities these images might have. This is where Trivy comes in. Trivy is another wonderful open source tool that helps us with this problem by scanning for vulnerabilities in container images, file systems, and Git repositories. Trivy looks for vulnerabilities in OS packages like Alpine, CentOS, etc., and also language-specific packages like NPM and Yarn. Trivy can also scan for configuration issues in infrastructure as code files that put these files at risk. And if you're familiar with or have heard of the term shifting security left, this is a perfect example of how to do that. Trivy can be installed as a binary and run on the command line, and it can also be run in your CI/CD pipeline in GitHub Actions, Jenkins, GitLab, etc.
All right, so we feel good about security and deploying to Kubernetes, but what happens when we onboard somebody new to Kubernetes who may not know these best practices? Human error has been reported as the most common cause of data breaches and hacks, according to researchers from Stanford University. And so that's where something like OPA, the Open Policy Agent, can come in handy to help minimize these problems. So if you're not familiar with the Open Policy Agent, OPA, it is essentially a general purpose policy engine that unifies policy enforcement across your stack. So OPA has a high-level declarative language called Rego that lets you specify policy as code and simple APIs to offload policy decision-making from your software. OPA can be used to enforce policies in Kubernetes, CI/CD pipelines, API gateways, and more. Now, if you're new to OPA and you may be thinking that I just strung a bunch of words together that all make sense in theory, but what does it actually mean? So a great example of this is that you may have an internal policy that states that nothing can be deployed to Kubernetes that is allowed to run as root. Or maybe we have a policy that says images can only be pulled down from our company's internal repository. We may not want somebody pulling down images from Docker Hub. Docker Hub has a lot of vulnerabilities in it, and a common problem people face is how do we make sure that our engineers aren't pulling down unverified or unsafe images into our infrastructure. These are great policies that can be written in Rego to ensure that your team remains compliant with the policies that you set forth. This way, even if you onboard someone who is new to Kubernetes and has the keys to the kingdom, they will be unable to deploy something to the cluster if it violates the policy you created in the Open Policy Agent. One quick catch to this is that OPA does not actually enforce the rules. OPA simply passes judgment on whether something violates the policy or not. In Kubernetes, a validating admission controller would need to enforce this OPA policy. So if you take a look here, here's a pretty basic Rego policy. We can see it's using this Kubernetes admission package, and we've got one rule here. So everything within the curly brackets is a rule, and each one of these lines 3 through 6, are conditions. If all 4 of these conditions are true, then the rule gets passed. And so if you look at it first, it's checking to see, so as soon as you apply something to Kubernetes, OPA is going to get the YAML manifest of what's coming in. And OPA is going to check the input.request.kind to look and see if it's a pod. If it is a pod, which is true, it's going to move on to the next line. And from here, it's going to look in that YAML manifest. It's going to grab all of the images in it and put it into this image variable. Now it's going to check to see if any of these images start with huli.com. And if they don't start with huli.com, which is the registry that we expect them to start with, then it's going to load this message here, and it's going to say, the image, it's going to put it in there, interpolate it, comes from an untrusted repository, and it's going to show the image. That's going to let this deny rule into effect. It's going to pass that over to the admission controller, and if you have the admission controller in enforcing, it's going to block it right then and there, and so it won't even be allowed into Kubernetes, or it won't be allowed to essentially be written in the etcd database from there. So it's kind of a quick overview of OPA and how that works. And from here, we have another polling question. So what is your greatest opportunity to improve your Kubernetes environment? Is it A, getting help with the basics, B, general best practices assessment? Maybe it's C, improving the security posture of your clusters. Is it D, saving money? Or E, improving the reliability of apps running in Kubernetes? So it's interesting when we work with, the various clients that we do, it's interesting seeing all the different areas that people want help in and seeing, how can we help you focus on security in your cluster or save money? And there's a lot of great tools for that. And we've talked about some things certainly with like Polaris looking at security checks and stuff like that. Helps with the reliability, all that good stuff. So yeah, just trying to get an idea of where you all are so we can maybe fine tune some of the things we talk about.
Looks like security or reliability is a big one.
All right. Yeah, it looks like best practices and security combined are about the same as reliability. Awesome. Thank you all. And from there...
Yeah, I think we want to talk a little bit about insights. We have all these different problems when we're working with Kubernetes, and there's a lot of open source tooling that can help us solve them. But how do we centralize all of this information so that it's not a ton of work getting everything set up to start giving us data? For this, Insights is a great resource that brings together many of these tools we've just talked about and more, and adds value by making it bigger than the sum of its parts. The features and functionality of Insights cover almost the entire maturity model. So no matter where you are, it has something useful. And I know we have some static slides on Insights, but Rachel, would you like to give a live demo today?
Sure.
That'd be great.
Yeah, got some tabs ready just in case. Let's take a look here. So yeah, this is the Insights platform. And the first thing you can see right off the bat is that we've got a lot of clusters right now coming into the platform. So there's maybe a dozen clusters or so. They're all reporting back so we can get a high level overview of how things are going, within Kubernetes across all of our different clusters. So if we look at one of them, for example, let's take this Alpha Prod cluster. And if we come over to the install hub, essentially, the way this works is that if Insights is the platform, we have all of these different plugins that feed data into the platform. So a lot of these you're probably going to recognize right off the bat since we just talked about them. We've got Polaris, which helps with configuration issues. If you're focused on reliability and efficiency, this is one of those tools you're going to want to look at right away because there's a lot of things it can tell you about how to improve reliability and efficiency. Some of you mentioned security, and we talked briefly about Trivy with security. Talked about Open Policy Agent for setting up those guardrails. Kubebench checks your cluster against the CIS benchmarks. If you want to upgrade your Kubernetes clusters, tools like Nova and Pluto are going to help with that. I know Grace spoke about Nova and how it helps you find out-of-date Helm charts. Pluto is going to help you find deprecated APIs in your cluster, another great open source tool. If anyone has upgraded their Kubernetes cluster to version 1.22 or recently gone through it, a lot of the Kubernetes APIs were deprecated in that version. And so Pluto is an absolute lifesaver for making that upgrade a lot more seamless and a lot easier. Some other plugins are things like RBAC Reporter, which is going to help you keep track of those roles and bindings. Kube Hunter is kind of like a penetration testing tool within your cluster. It's going to show you where some of those weaknesses are for those that are particularly interested in security. And then we've got things like the Prometheus Collector and workloads. Those are going to give us cost recommendations. So if you're trying to figure out how to save on costs, since I think I saw a statistic that something like 60-ish% of people are spending more on Kubernetes than they need to, this is one of those ways to cut down on it by seeing how much resources we're actually using and then getting recommendations for how to lower those to save money. And then we also saw the admission controller. That's running in conjunction with the open policy agent. So the open policy agent is kind of like a bouncer outside of a nightclub or something. And if you are on the list, you can come in. If you're not, you can't come in. And open policy agent is the one defining that list. And then we also have Goldilocks, which also gets CPU and memory settings for each workload to do different recommendations there. So there's all these plugins, and you can absolutely install these yourself. I think everything here, I want to say, is open source. There might be one thing that's not. Actually, I think it's all open source. But all of these plugins are going to generate reports every hour if it's running in the cluster. And then it's going to surface it in the platform so you can get a centralized view of all of the things that are going on. And so if we go over and look at action items, right off the bat, these are all of the reports that are coming in from the plugins. So if we look at reports, we can see everything installed here. We've got Polaris, which we just looked at, Prometheus metrics, all of these are running inside of your clusters. If you have 10 clusters, you have them running in all these different places. And now they're all coming into this platform. And if we filter by Polaris, for example, right off the bat, it's going to show us how common some of these issues are. We can see they're in various clusters here, like privilege escalation should not be allowed, comes up quite a few times. It looks like the most common one, though, is image pull policy should be set to always. There are 378 instances of this across all of our clusters. And here we can see that, it's multiple clusters, London staging, Alpha staging, US West staging. So as you get more Kubernetes clusters, if you need to, it's going to help you keep track of that so that you can eventually put policies in place that scale across all of your clusters. Again, this is all open source. Feel free to go play with it, but it becomes a little bit of a maintenance overhead trying to keep track of everything, especially as your clusters grow and there's a lot more stuff to do. So this is a really nice way to get a good overview of everything going on in all of your clusters. You can see different severities, whether they're high, medium, sometimes critical will show up in here, along with the namespaces where they show up most often. In this case, the geode application. Maybe that's a particular team of developers that are deploying, and maybe they didn't get the training that shows them how to set CPU requests and limits or memory requests and limits, because that's going to allow our cluster to be more reliable and allow it to scale out horizontally. And so that's a great way just to see where we, which namespaces need more room for improvement. And we can even drill down there to get more information. Should not be allowed to run as root is an issue that comes up a lot there, and a lot of other good stuff like that. So let's see, what else? We talked about a lot of those plugins, and we took a look. For efficiency and cost, another great thing is Insights is going to show all of our different clusters and how many resources they are using and how much they cost us over time. So we can see over the last month, on particular days, maybe things were more expensive. Maybe we rolled out a new service or something and it's getting a ton of traffic, and we can see how that's affecting our cloud spend. And so it's a great way to get a high-level overview of how much Kubernetes is costing us. We can break it down by individual cluster here. This is going to show us what is the total capacity of this cluster. This one's probably running on Minikube for this demo environment. We can see it's got 4 CPU cores available to it. It's only using just under 1 CPU core, so it's only using 25% of what it's got available to it. But we can see here it's requested, almost 3 CPU cores. So what you request is what you're going to get in Kubernetes. It's going to make sure that you have that much space so that when your resources need those, or when your workloads need those resources, they're available to it. And as it starts to grow, it's going to scale out horizontally and procure more nodes so that you can, continue to scale without issues. You can also see the limits are set way out here to 10 CPU cores. It's very common for people to set a limit higher since they don't actually use all those resources, but you can burst up to that limit and use more than you need. And so, yeah, it's a great way to quickly get a quick snapshot to see how efficiently I'm using this cluster and if there are things I can do to cut down on, cloud spend. There's other things, it's showing the CPU utilization. Over here, we can see that things started to spike on this particular day. Maybe this is when we rolled out that service. We can also look at things by memory. Maybe our workloads are more memory heavy, and so that's the constraint that we're working with. Gives a lot of options for seeing what it is that you have and what you're using, and how to tweak things from there. Additionally, so if that's at a high level of the cluster, we can also drill down a bit. So let's say we go into this US East staging cluster. We can choose our cloud provider. Let's say we're on AWS, and let's say we're using, let's pick an M5 instance, since those are pretty common general instances. So let's say our cluster is using a whole bunch of M5 4x larges. We've got reserved instances. We can go ahead and put this in, and it is going to calculate how much each individual workload costs us. So in that previous screen, we were just seeing how much the entire cluster was costing us. Now we can see how much each individual workload is going to cost. So if we look at something like, here we've got this Insights agent. It is running and it costs about $22 a month. It looks like on average, there are about 3.55 pods running at any given time. And so it's going to give recommendations. It's going to track the memory and CPU usage over time. And then based on that, it's going to give recommendations. And so from here, if we had a resource that was wildly over-provisioned or requested way more CPU or memory than it needed, it's going to recommend a significantly less amount of resources. And you can see a lot of cost savings there. We actually, we manage, I don't know, maybe 100 clusters or so for various clients. And in one of them a while back, we saw an opportunity where this was showing us different recommendations that we could use. And they put those into place. And for them, that had a huge impact, because they had a situation where one of the workloads they deployed had 30, 40, 50 different pod counts, and then they had tons of different deployments. And by making those recommendations, they ended up saving tens of thousands of dollars a month. And so a lot of teams will create a deployment YAML manifest. They will copy it around, paste it, share it with other developers. And it doesn't take into account the different resource needs. And so people are just using the same amount every time, because that's what this person on this other team got to work in Kubernetes. And that's where cloud costs can grow pretty quickly. So yeah, again, very powerful thing. Great for seeing how we can make Kubernetes even more efficient. It's a brilliant tool, but there's a lot of things that we can tweak and make it even better. What else? So we talked about OPA policies a little bit. Here are a few examples. We've got a policy library where we can create some from templates. This one in particular, DNS hostname, is too long. We had an issue with one client where they would create a resource in Kubernetes. It was a pod that was handling some web traffic. And so it needed a certificate to be generated for, TLS traffic, all that good stuff. And there's an RFC, looks like 3280, that says that, the common name should not exceed 64 characters. And it turned out that whenever they were putting this resource into Kubernetes, there's a wonderful tool called Cert Manager. It will automatically get certs for you and renew them every 3 months or whenever you need them renewed. And whenever they were creating these resources in Kubernetes, Cert Manager was trying to create a certificate for that resource. It would go off to Let's Encrypt, some authority, and say, hey, I need a certificate. Let's Encrypt would get it. It would see that the common name was 80 characters or so, and it would just fail right away. And so over and over again, month after month, this client still kept putting resources into the cluster that could not get certs. And then they would wonder why why wasn't their thing working? Why does it say that big scary website about not being a authorized connection or a safe connection? And it turned out this was why. And so we set an OPA rule up to where anytime they try and create an ingress, the ingress is the traffic or the path into the cluster. Anytime they create an ingress, it checks to see if the host name is longer than 63 characters. And if it is, it's going to go ahead and either block it or create an action item right then and there. So rather than them going a week and then wondering like, hey, I wonder what happened with that app, they can immediately get notified and figure out, what the issue was right at the time that they deploy it into the cluster, which shortens that cycle pretty significantly. So that's just one example of like the custom things that you can do with Insights. Again, it's building upon all these wonderful open source tools, adding a lot more power to it. And one thing I like to think of is, if this is a platform that aggregates all of this data, each action item kind of acts as a trigger. And so as an action item comes in, we can use that trigger to do something, some type of behavior. So if let's say a security action item comes in and we want to be notified right away, we could say, if a security action item comes in and it has a critical vulnerability, I want you to send me a message on Slack right away in my security channel. And you'll get notified in Slack immediately as soon as you pick up on something like that, because it'll be sent to the back end. It'll notify you in Slack and do all of that. There's also other great stuff, like if the CPU limits are not set, you can have it immediately create a ticket in Jira. You can send it to the team that's working on it. Like if a action item for CPU limits comes in the Team 34 namespace, immediately put it on their Jira project board so that way they can tackle it themselves, pushing service ownership to the teams themselves. You can also send things to PagerDuty. There's a lot of different ways to configure that and play around with it. Just to wrap things up, those are all running in the cluster. You can also shift this left into your CI/CD pipeline. So this is a great situation where you can catch all of these things before they even get into your cluster. So like this particular resource, it's a deployment, looks like it's a MongoDB container. This action item that said file system should be read only has popped up. And we can find that as soon as a developer, pushes a commit into GitHub, it could trigger, GitHub, other places. It can trigger a GitHub Actions or some other CI process to run these checks against it and surface it before it even gets into your cluster. Another great way to save time. And then finally, for those of you that mentioned security, there's a centralized place for where to see vulnerabilities in the cluster as well. And so we can see like, Jenkins here, for example, in this Gov Cloud Prod cluster has some vulnerabilities. Looks like it's got 658. We can take a look and it's going to start to show us what those vulnerabilities are, how we can potentially remediate them if there is a fixed version later on. Maybe there's not a fixed version. We can filter them by the severity, the packages they're in, all kinds of great stuff like that. So yeah, at that point, I feel like that is a pretty good high-level overview. What else? Let's see. Going back to these slides, we do have a Kubernetes white paper. It is on Kubernetes best practices, and it's got all kinds of stuff that we just talked about: security, cost optimization, reliability, policy enforcement. And yeah, from that, I'll leave up this closing slide. Happy to take any questions and answers. Grace, do you want to wrap up with this?
Yeah, thanks, Rachel, and thank you for demoing that for us. I'm sorry to surprise you with that, but you were very prepared. Thank you so much.
Gotta be ready.
So yeah, I love it. So yes, you can find all of these resources on this slide here. And to recap, we talked about how to think about deploying to Kubernetes with Helm and Reckoner to keep deployment resources nice and tidy, as well as how to keep Helm charts up to date with Nova. We then took a look at Kubernetes configuration challenges and how Polaris can tell us whether our cluster is following best practices or not, along with tips on how to fix it if we aren't. We discussed how to think about security in the cluster with image scanning tools like Trivy to help keep us safe from supply side attacks by scanning all of our container images for vulnerabilities, as well as how to enforce policy with the Open Policy Agent. Finally, we took a look at insights to see how it can help us solve the problem of costs in Kubernetes, inform us on how best to configure our cluster and connect us to the information we need, whether it be via email, Slack, or PagerDuty. I hope when thinking about these problems, you'll find these tools useful in making the managing of your cluster more effective. And if you'd like to chat with someone about help in any of these areas, please reach out to us. We have a lot of engineers and developers who spend all day, every day thinking about Kubernetes, and we'd love to chat with you. So don't hesitate to reach out. And we'd love to answer any questions you might have.
So Rachel and Grace, I'm not seeing any questions at this moment. So while we give our audience just another minute or so to send in anything, how about we give away those Amazon gift cards I mentioned at the beginning of the hour?
That sounds great.
So our first winner of our $425 Amazon gift card drawing is Claudine D. Our second winner is Miguel S. Our third winner is Katie L. And our fourth and final winner is Vern W. I also take this opportunity to remind everyone that this session was recorded. You should be receiving an email with a link to access the recording on demand. You can also find the recording living on the DevOps website. Just visit devops.com/webinars and be sure to look in the on-demand section. So we just received one question, so maybe this one will kick off a few more. So how do you handle API interfaces?
Could you be a bit more specific about what type of API interfaces you're talking about?
And while we wait for some clarification, another question reads, does this work in Azure and AWS?
Yes. Yeah, Insights will work in Azure, AWS, GCP. We manage clusters for clients in all of those different cloud platforms, and we've got it running there as well. So yeah, it certainly does.
Awesome. So I'm not seeing any more coming in. So before we close out, is there anything that the two of you would like to share with our audience? Any farewell messages, anything like that?
I'm super happy you all joined. Thank you so much for your time. And yeah, if you have any other questions, we'd love to chat. So please don't hesitate to reach out.
Yeah, please reach out and let us know if you end up spinning up any Minikube containers or anything like that. We'd love to look at it with you.
Awesome. Grace, Rachel, thank you so much for taking the time to join us and for putting on this presentation and demo. I'd like to thank Fairwinds for sponsoring this webinar. And before we close out, of course, I'd like to thank our audience for joining us. Please, we ask for one extra moment of your time to fill out a brief post-webinar survey that should pop up on your screen here in just a moment. But otherwise, we do hope to see you at an upcoming TechStrong Learning webinar or workshop. So everyone have a great rest of your day.